Let's take a look at Azure Machine Learning, starting at the very top. Welcome to this video on Azure Machine Learning. My name is Kevin Fiesel. I'm the proprietor of Catalxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. We're going to start a new series on Azure Machine Learning. This will be a multi-part series where I'll start with the basics of how it all works and move down from there. Along the way, we'll have videos on automated machine learning, using the Azure ML Designer's graphical user interface, writing code against the Python SDK, and even implementing a simple form of ML ops, machine learning operations, using GitHub Actions. There's a lot of ground we're going to cover, and this series will supplement 3 separate presentations I deliver on Azure ML. If we want to start with Azure Machine Learning, I think it's a good idea to understand what it is we're getting ourselves into, and that means an architecture diagram. This is a fairly involved diagram, so let's take it one step at a time. First, in the middle, we have the workspace. This is the central core of Azure ML and how we'll interact with all of the AML components. This includes a web interface in Azure ML Studio, but as we'll see later on in the series, you don't have to use that web interface for everything. In order to create a workspace, we're going to need to have several additional services in place, though when we create a workspace, AML can provision these other resources if we don't have them already. The first service is an Azure storage account. Azure ML uses this storage account to create a blob storage container as well as a file share. The second is an Azure Container Registry. When we train and deploy models, we're building Docker containers hosting our code, so we can isolate the code and not have to deal with version conflicts or cleaning up code messes. If you have a new version of a model, deploy it out as a new container and take down the old one. Most of the container work is abstracted away, though for troubleshooting scenarios, you're going to want to understand the basics of how containers work, as you might end up troubleshooting problems locally. The third service we need is an Azure Key Vault. Key Vault allows us to store secrets in a secure fashion. Instead of storing database connection strings, shared access signature tokens, and the like in your notebooks or your Python scripts directly, you can and should keep those in Key Vault. Our final requirement is Azure Application Insights, a service which tracks and stores application logs. Once we have those dependencies, we're going to need to create some compute. Compute in Azure ML comes in 2 flavors, compute instances and compute clusters. Think of a compute instance as a virtual machine for your data scientist. My recommendation is that each data scientist gets a compute instance. If the data scientist wrecks the compute instance, that's fine. Blow it away, create another one. The nice thing about compute instances is that we don't store our data on there. That's what the storage account is for. Azure ML does a great job of separating compute from storage and letting us treat compute as ephemeral in multiple senses of the term. Compute clusters, meanwhile, are sets of machines we use for training larger scale models. If the compute instance is a virtual machine for a data scientist, the compute cluster is a beefy shared server. One nice thing about compute clusters is that they shut themselves off if they aren't performing any work. So you can provision a powerful cluster which might cost $20 or even $200 an hour, but for the hours of the day when nobody's actively training, that cluster is off and you don't get billed for it. By the way, before I scare anybody off with thoughts of paying like $150 a month on Azure ML compute, I should note that in most of the circumstances I've dealt with, the compute cluster is more like $1 or $2 per hour. But if you've got the kind of computational needs that $150 large is your bill, I'm pretty sure Microsoft will be happy to take your money. Of course, not all your data, or all of your compute, will be in Azure ML directly. That's where linked services come into play. Linked services are optional, but you'll probably create new data stores. Data stores are the other services which host data. As of the time of recording, there are 7 data store types, all of which are Azure services. The other linked service is a compute target. As of the time of recording, there are 5 possible compute targets for us, most of which are Spark-based compute from other services like Databricks or Azure Synapse Analytics. We can also bring in our own data science virtual machines rather than relying on compute instances. By the way, in the interest of maximum confusion, there is also a concept in Azure ML known as the linked service, capital L, capital S. The only linked service available is to Azure Synapse Analytics, and attaching Spark pools to it is deprecated functionality, so that's the last I'm going to speak of it here. Once you have your dependencies, your managed resources, your data stores in place, we can get to the fun part of Azure ML, the assets. These are the different things we can create and work with in Azure ML, and I'll break it up into a couple of mini sections. Data sets are what they sound like, discrete collections of data that you can use for the purposes of training a model. We train a model in an environment by creating a training pipeline, and can try this with different algorithms and processes as part of one grand experiment. Then, when we're satisfied with our trained model, we build an inference pipeline to allow other services to call our model with new data and get back results. As one consequence of building an inference pipeline, we can deploy the pipeline as an endpoint, at which point Azure ML wraps our model with a REST API and makes it accessible over HTTP, letting us send in JSON requests and receive JSON responses. That was a mouthful, but I think it'll get a lot clearer once we see Azure ML in action. Welcome to the Azure portal. We are going to work with Azure Machine Learning, so in case this is your first time through, let's walk through the process of creating a new workspace. I'm going to type in Azure Machine Learning into the search box and pick the Azure Machine Learning option. I already have a workspace, and that's what we'll end up using. But before that, let's walk through the process of creating a new workspace in case this is your first time. We'll do that by selecting Create and choosing New Workspace. On this screen, we'll need to make some decisions. First, choose a subscription and a resource group. I'll just choose my existing CS Azure ML resource group. Next up, I need to create a workspace name. This only needs to be unique within your own resource group, so you can use almost any name you'd like. Note that this auto-populates values for storage account, key vault, and app insights. I'll leave those the same, though if you already have resources created, you can use those instead. We can also pick the region, so of course I'm going to put it in East US along with everybody else's in the world. And as for container registry, we don't need one immediately, though I happen to have one already, so let's use it. On the next page, I can choose to use public network or private endpoints. The tab after that is the Advanced tab and lets us handle things like managed identities and data encryption. On here, I don't mind using a system-assigned managed identity. You can also choose to use that managed identity or a set of credentials to access your storage account. Though if you do go the identity route, make sure that you grant storage blob data contributor on the storage account to the managed identity for the Azure ML workspace. The third option covers whether you are okay with using Microsoft's encryption keys or if you want your own encryption keys for your data. Finally, at the bottom, you can check this box if this is a high business impact workspace, and then Microsoft will limit the diagnostic data they collect. I'll leave this unchecked as it'd be cruel to check the box and deny that diagnostic data. We can then get a last check on our Azure ML workspace, and if you're happy with that, select Create and go forth. But I'm just going to close out of this and go to the workspace I already have. In there, I can select Launch Studio to jump into Azure ML Studio. Azure ML Studio is the web experience for Azure ML, and you can do a lot inside of it. I'll first navigate to Workspaces and choose my workspace from there. And here's the workspace. We're going to start by going to Compute and then checking out what I've got available to me. Here's a compute instance called CS Compute. I can start it up by selecting it and choosing Start. As a quick tip, I've set up a pair of ways to save money. One is an idle shutdown of 1 hour, which automatically turns off the machine if I don't do anything for an hour. The other is a schedule which shuts down every day at midnight, or 11 p.m. sometimes. Stupid daylight savings time. In the Compute Clusters section, I have a few of these set up, including one which provides me GPU support. I can choose from among these targets based on how much I'm willing to pay for a particular job in terms of money and in time. In the Data tab, I have an access to a variety of data stores and data sets. As you can see, I already have a few data stores I've set up previously, including my default blob storage and file share. I also have a few Azure SQL databases and blob storage accounts set up. Creating a new data store is easy by selecting the Create option. The setup is fairly straightforward, though we're limited to a set of Azure data store types here. Then, once we have those data stores set up, we can add data assets. You'll see quite a few data assets here. I've had this workspace for a while after all. If I want to add a new data asset, I can select Create. I'll give the asset a name and choose a type. Looking at the Azure ML v1 API list, there might be a little confusion. A file dataset type in the v1 API actually means binary data, like video or images. Tabular, meanwhile, represents anything which you could conceive of as fitting in a table in a database. So, for example, if I have a CSV file of data that I want to analyze, I'd actually choose tabular rather than file. For the v2 data assets, I can upload individual files, entire folders, or ML tables, which are folders that include an Azure ML materialization blueprint. Note that if you're dealing with a single, simple CSV file, you'll want to choose v2 file rather than table. I'll choose v2 file and then navigate to the next section. Here I can upload a local file, pull it from a storage account, or get it from a URI if that data is publicly available. I happen to have the data asset that we'll need for this series uploaded already, so let's close this window. The data asset we'll use is Chicago parking tickets, a sampling of 1 million parking tickets from the city of Chicago. Choosing this data asset, I can select Explore and get a feeling for what kind of data is inside the asset. We'll talk more about that in the next video, but for now I just wanted to note that it exists. The next thing that I want to cover is jobs. The jobs menu shows our experiments. Think of an experiment as a thing you want to accomplish. For example, I want to explain some phenomenon given my input dataset. I might try a series of different things to explain, such as trying out different algorithms or tuning hyperparameters. I can group all of these attempts together in a single experiment, like my Chicago parking tickets designer. Inside there, I have 2 jobs, that is, 2 times I executed a pipeline. Clicking on the bottom one shows me my training pipeline and its results. The top one would show me the inference pipeline. I can also see these by selecting the Pipelines option and looking at the Pipeline Jobs menu. Usually, when we train a model, we want to use it later against new data. To do so, we can register the model and have it be available in the model registry. You can see here, there's a model that Azure ML Studio created for Chicago parking tickets, and if I select it, I can get some important information on it, including any endpoints using that model. Speaking of endpoints, we can see those in the Endpoints tab. Azure ML endpoints are intended for real-time inference, meaning you call a REST API with some correctly formatted JSON, and you'll get back a JSON response containing the results of your prediction. If I were to click on one of these endpoints, I'd see the URL I can use to call that endpoint, as well as details on its current status. We'll see how to create an endpoint later on in this series. The last thing I want to talk about is environments. Microsoft provides a set of curated environments, which come pre-installed with a variety of products. For example, we can see various environments which include TensorFlow, PyTorch, and more. The set of curated environments does change on occasion, so watch out for that. You can also create your own environments, which are essentially Docker files with instructions on how to customize the environment and what Python packages we need to install. And that is Azure ML, or at least a really high-level overview of the product. Of course, we haven't actually done anything with it yet, but we will. In the next video, I'm going to take you through Azure ML's automated machine learning functionality, and we'll train a model, or a few hundred. We'll have links and show notes in the description below, and until we see each other in the next video, take care.